Okay, so we've already looked at lots of different ways we can think about logarithms and apply logarithms. We've derived some laws too. Let's now think about logarithms as an operation, like multiplying or dividing or raising to a power or square rooting, right? Okay, we can think of logarithms in the same way because let's just use this first example here, look, because if y is equal to a squared b, then surely log of anything, y, is going to be equal to log of a squared b. Does that make sense? Right? Okay. Because what is it I raise 10 by to get y is going to be the same number I raise 10 by to get a squared b if y is equal to a squared b. So that is something we can certainly do, right? Okay, we've written a logarithmic equation there. Now, maybe I could expand it and make it a little simpler, in some respects simpler, because I could split this into log a squared plus log b, because a squared b I'm multiplying and I can use that first law. I could even go so far as to bring that 2 down as well, right? And write it just like that. So that's the sort of thing we can do if we think about logarithms as operations on either side of an equation. Let's, I think, skip forward and take a look at something like this. Let's try to do the opposite now. Let's try to write these equations without logarithms. So in order to do that, rather than taking logs of both sides and adding a log, let's try to get them equal to logs, and then we can drop away those logs, right? So what I mean by that is, first of all, let's start work on that right-hand side and put the 2 up top with that third law, look, okay? Now we can bring those two different terms together on the right-hand side and say we've got log of bc squared. Now we've got, look, log of something equals to log of something else. Well, again, now at this stage, we can drop those parts. So we could just say that a is equal to bc squared. So look, that was the opposite way round, but of course the same as that first example. Let's take a look here and see if we can do something similar to part B. I'm going to start working on that right-hand side first. We've got base 2 stated this time. Again, I can bring that 3 up. So we're going to have a cubed. The minus 2 is tricky to deal with, but we can deal with it because let's just write a nice 1 in a different format, right? Minus 2 times 1 is still minus 2. That will be log 2. Right? What is it I raise 2 by to get 2 is just 1. So this is necessary because I had the base 2 here, right? And I'm only going to be able to bring these logs together if I create that place with the same base. So now that I've done that, let's keep working on that right-hand side. We'll keep that just as it is for now, but we can bring that 2 up. So we're going to have minus log 2 of, I'm just going to jump to 4 because 2 squared is 4, okay? Now then, from there, what we can do is we can bring that right-hand side together with that second law of logarithms. So log base 2, a cubed over 4. And again, I can only do that because I had the same base. Otherwise, that law does not work. Right, from here, we've got log base 2 happening to both sides. So if that's true, well, m must equal to a cubed over 4, and I am finished. Okay, so hopefully that was some nice examples of how you can apply logarithms to both sides, or you can drop logarithms from both sides if you can create the conditions for